All right, this is the notes for 5.4. This is scientific notation. This is a pretty short section. Just keep in mind that this is sort of the inflection point, the bridge point in this unit. So we sort of shift gears after this. This is like the bridge from one part to the next. So scientific notation you have seen before. It's a positive number expressed in the form a times 10 to the n, where a is a number between 1 and 10. Okay, when n is an integer, positive or a negative number, it's said to be written in scientific notation. In scientific notation, there's only ever a single digit in front of the decimal. That's how you know you did it right. So if it's 22 point something, it's not in scientific notation. That's not how you can have an answer. It's not a correct answer if it's written like that. So to write a number in scientific notation, what we do is we think about where the decimal is. So for 53,000, the decimal is at the end after the last zero. To write it in scientific notation, I need to think about moving that decimal 1, 2, 3, 4 places. I want it to go between the 5 and the 3. And so what I have to think about is what I would multiply 5.3 by to make it 53,000. I would multiply it times 10 to the fourth. I would multiply 5.3 times 10,000, which is what 10 to the fourth is, to make it 53,000. Try that in your calculator. 5.3 times 10,000. It gets you 53,000. These are equivalent representations of the same number. In the other direction, so we want this decimal to go in the same place. I want this to be 5.3 again, but it's a different number. It's very, very small. So I'm going to multiply 5.3 times something very, very small to change it into, let's see, tenths, hundredths, thousandths, 10,000ths, into 53 hundred thousandths. So instead of a positive exponent there, because I'm turning this number into something really small, I use a negative one, and it's the number of places I move the decimal. So 1, 2, 3, 4, 10 to the negative fourth. This is the difference. This is a big number, 10 to the fourth. 10 to the negative fourth gets me a small number. All right, so the same thing with 175 million. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. I want this to be 1.75, and I can multiply 1.75 times 10 to the 8th to get 175 million back. It's just a different way to write that number. And to do, this is 1, 2, 6. I want this to be 5.0. There has to be one number in front of the decimal. So the decimal's got to move behind the 5. And I would have moved it 1, 2, 3, 4, 5, 6 places. So 10. And I know it's a negative 6 because I'm making a really small number. And 10 to the negative 6 is a really small number. It's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions, right? So it's 1, I'm going to multiply 5 times a millionth, th, to get that really small number. So to write, these are the other examples. Sometimes you're going to get them in context. So the number of movie tickets sold in the United States for a recent year, probably not this year, is estimated to be 1,500,000,000. So we don't talk like that in our day-to-day life. So I'm going to move the decimal between the 1 and the 5. I'm going to count how many places I moved it. 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it 9 places. I'm going to make it a really big number, so I need a positive exponent. 1.5 times 10 to the 9th. This one, I'm going to make a small number. The decimal is going to be between the 6 and the 6th, 1 digit ahead of the decimal, times, let's see, 1, 2, 3, 4, times 10 to the negative fourth. And here's the thing, you have a calculator. So if you're not sure that you did it right, multiply it through in your calculator. Put what you see in scientific notation in your calculator, see what you get back. Okay? Negative 43 degrees. Well, to be in scientific notation, the decimal's got to be between the 4 and the 3. So negative 4.3 times, I moved the decimal once to make a bigger number, times 10. So negative 4.3 times 10 is negative 43. This last one is obnoxious, but it is. So this number is already in scientific notation. It's already set up the right way. So all I need to do is multiply it by a power of 10, but like what? I don't really want to multiply by 10. I want to multiply by 1. I want to keep it the same, but it's handy. In the last section, we know anything to the 0 power is 1. So 8.2 times 10 to the 0 power is really 8.2 times 1, and that will work. All right, so write the numbers in standard form. This is going the opposite direction. The mass of a proton is approximately 1.67 times 10 to the negative 24. The first question is just think to yourself, really big number or really small number? Well, really small number. So it's going to be 0 point, and then I'm going to need 23 zeros. I'm going to run out of space. So 23, 1, 6, 7. That's my number, which is why we don't write them out like that. This is exactly why we use scientific notation, because who would be able to get that right if you were rewriting it? The nearby star Vega is approximately 1.552 times 10 to the 14th miles from Earth. So think about it. It's a really big distance. It's really far away. So I'm going to move my decimal to the left. So it's going to be 1,552. I have 14 spaces to move, so that's 1, 2, 3 I've already moved. That means I have 11 to go. 4, 5, 6, 7, 8, 9, 10, 11. Let me check. 1, 2, 3, 4. So that's 14. Oh, 11, 12, 13, 14. Okay, 11 zeros, I can count right. So that is the actual distance. All right, there is a missing term here. This should be 5.5 times 10 to the negative 8. The probability of winning the California Super Lotto jackpot is 5.5 times 10 to the negative 8. Big number or small number? Like, do you have a really good chance of winning the lottery this week? No, not so much. So I'm going to 0 point. I'm going to move it to the right, sorry, to the left 1. And then I need 7 more spots. 2, 3, 4, 5, 6, 7. So my odds of winning the California jackpot lottery right now are pretty dang small. The sun's mass is 2 times 10 to the 30 kilograms. It's a really big number, right? So use your context. So you're going to put 2 with 30 zeros after it. Because the decimal is right here at the end of the 2, I'm just moving it 30 places to the right. But I'm not going to draw them all because I love you guys. You don't need to watch me watch zeros. Write zeros. All right. So this is the trick to this section. It's not super terrible. But what we do here is we do numbers and tens. So the first thing you're going to do is multiply 8.7 times 2.5. I'm going to get 21.75. And then I'm going to have 10 to the 4th times 10 to the 12th. Well, that's 4 plus a negative 12, 10 to the negative 8. And now I have to evaluate, is 21.75 in scientific notation? No, it's not, is it? So what I can do for just a second is ignore this 10 to the negative 8 for just a moment. If I had 21.75, I would rewrite it as 2.175. It would be times just 10 to the 1, positive 1, because I'm making a bigger number, right? That's what I would do to get 21.75 back. So then I have 12.172, or 175, pardon me, times 10 to the 1, and then times 10 to the negative 8. Well, 10 to the 1 and 10 to the negative 8 is really 2.175 times 10 to the negative 7. Okay. Do the same thing in the second one. It's just division. So 4.25 divided by 8.5 is going to get me 0.5. And then I have subtraction. 10 to the 13th minus 10 to the negative 2 gets me 10 minus negative 2 is plus 10 to the 15th. Well, as it is, I can't have that like that. So I have to think about, I want to make 0.5. I'm going to separate that in my mind for a second. I need to make 0.5 into 5. So the way I would make it smaller is times making it 10 to the negative 1. So 5 times 10 to the negative 1 is the same as 0.5. So 10 to the negative 1, then times the negative 10 to the negative 1 times 10 to the negative, not negative. Let me say that one more time. 10 to the negative 1 times 10 to the 15th. So I have 5 times 10 to the 14th is the final answer. Okay? All right. Last ones. You try these two. Let's see what you get. If you get stuck, come into the discussion. The final answer for the first one should be 3.5 times 10 to the 9th. The answer for the second one should be 2.5 times 10 to the 4th. If you're stuck, come talk about it in the discussion. You know what to do. I will see you in the next section.